Hello ladies and gentlemen, so today we're going to look at section 13.3 day 2 on how to evaluate trig functions of any angle using the unit circle. So you're going to want to have a calculator today, you're going to want to have your pen or a pencil, you're going to have your notes, and you're definitely going to want that bright green unit circle chart that you got today, because that's going to be very important. So let's review a bit about converting between degrees into radians. So if you remember, when you're writing degrees to radians, you're going to go degrees over 360 equals the radians over 2 pi. Okay? Now, what's going to do? You're going to be able to change every single one of these. Now, let's actually write the radians next to the degrees, okay? So you're going to want to pause here for a quick minute and definitely write down all of the radian measures besides their counterparts in degrees. So pause right now and then write those down quick. Go back? Perfect. So your unit circle. This is what's called the unit circle. It has a center at 0, 0. It has a radius of 1 unit. What this allows us to do, it allows us to add some coordinates to this picture as well. So, if my radius is 1, that means from here to here is 1 unit, right? So this would be 1, 0, because I didn't go up at all. So that would be 1, 0 for a particular unit. Right here, if I go up, oh, that's not a very good color. Let's pick a better color here. Let's just go red. If I go up this way, right here, this would be negative, oh, not negative 1. That'd be 0, 1, wouldn't it? 0, 1. So I didn't go left or right, but I did go up 1. There we go. Going this way, negative 1, 0, because I went back 1. And then this way would be 0, negative 1, because I went down 1, right? So we write all those down. Go ahead and mark those in for those particular degree marks. Those are going to be very useful today. So now, unit circle. Write this on the chart. So we said our origin was at 0, 0, had a radius of 1. So to understand sine, cosine, and tangent with this circle, let's think about the reference triangle for this unit circle through the general point xy. So right here is xy, right? Drop my perpendicular down. I went x units this way and y units that way, right? Now, from here to here is the radius of my circle. If I have a radius of my circle, I said the radius was 1, right? So that's got to be my r, which is equal to 1 at all times. Now, if here's my theta, my reference angle that normally we've been making, right? So across the way here, this would be my opposite, this would be my adjacent, and this is my hypotenuse. So what this allows us to do is fill in, when we just get a point, we can find our sine, cosine, and tangent. So my sine, in fact, would be my y over my r, which r is always going to be 1, so it's going to be y over 1. Okay, cosine of theta, that is adjacent over hypotenuse, which is x over r, aka x over 1, because your radius is 1. Tangent of theta is your opposite over adjacent, aka y over x. Go ahead, make sure you get those on your chart, okay? So, the main question you're probably asking right now is, why do I need this and when should I use this? It is our best knowledge of the unit circle when we have a quadrantal angle, aka an angle whose terminal side makes it impossible to draw a reference triangle. Look at this, sine of 270. 270 is right here, right? I don't know how to draw a triangle on that. Can't, don't know how, never figured it out. But you know what you can do is 270 on the unit circle would be 0, -1, right? Well, here's my x and here's my y, and we said sine was y over r. So if my y is -1 and my r was 1, my sine of 270's got to be -1. So what this allows us to do is figure out 90s, 180s, 360s, 270s, and anything in between. This allows us to not have to draw reference triangles for those that are impossible to draw. So let's actually use this a few times. I have the reference angle of 270 degrees. So right here, here's my sine, my cosine, and my tangent, just to give ourselves an idea here. So right here is 270. Remember, that is at 0, -1, right? So then, my sine of theta is going to be my y over my r. Remember, r can just be considered 1. So sine of theta would be y over 1. So -1 over 1, -1. Cosine of theta, x over 1. My x is 0. 0 over 1, well, that's just 0, right? Tangent of theta, y over x. Y is -1, x is 0. Uh-oh, look, I have a denominator of 0. Bad news. That means this is undefined. Can't get it. Error happens on the calculator. Bad things happen. What about cosecant? Well, what that is sine flipped. So that's going to be 1 over -1, aka still -1. What about secant? That would be 1 over 0, right? Because that's cosine flipped. Well, that's bad news again. That's undefined. What about cotangent? That is 0 over -1, because that's tangent flipped, right? That's just 0. So notice how your answers almost are, there's only like 4 answers you can get on this problems. And we'll discuss that on the next slide here. What about pi over 2? Now, if you look at your diagram, your unit circle that we made together, pi over 2 is also 90 degrees. So, let's figure this out. At 90 degrees, what did we say that was? We said that was for a sine of 0 and 1, right? 0, 1. So, if I have sine of theta, y over r. Remember, r is always 1. So my y over my 1, my y is 1 over 1, so that's just got to be 1. Cosine of theta is x over r, 0 over 1, because my x is 0, r is always 1. Tangent of theta, y over x. Y over x. Bad news, that's undefined again. Okay, what about cosecant? That should be sine flipped, so 1 over 1, still 1, haven't changed much. Secant of theta is 1 over 0. Bad news bears, that's undefined. Because I have 0 on the bottom, right? Cotangent of theta is 0 over 1, which is just 0. So now, here's a good thing to live by on these kinds. You can only get 4 kinds of answers, okay? So all answers are either 1, -1, 0, or undefined. You're not going to get 2s. You're not going to get 3s. You're not going to get 4s. You can only get a 1, a -1, a 0, or undefined. There are no other choices that you have for an answer. Some of these, you're going to get multiple repeats of the same problem because there's only 4 for you to choose from. So always pay attention. Make sure you know what angle you're looking for. These are pretty simple once you know your sine, cosine, and tangent. So try to keep that card handy and try to keep these in your mind, all right? And that's the end of this video. This is Miss Marsh, signing off.